All right, thanks kids for tuning in to the Unit 3 review. We're going to go through this fairly quickly because it's a nice review, which you already know how to do most of these things. Let's just kind of go for a quick little refresher here. This first angle here, I wanted you to measure it. I kind of have this protractor already on the page just to help me out. I decided to pick this bottom base. This bottom line as my base. I'm going to line my protractor up on it. Have the dot lined up right there, so my dot is here. Right around there. Take a look. It looks right here on my, it is a little bit less than, oops, that's not very good. A little bit less than 90. So I'm going to go ahead and name this angle 89 degrees. If it's 89 degrees, this makes it acute. Now, if you measured 90, it doesn't mean it's wrong, but if you measured 90 degrees, I hope you marked it as a right angle. And if you measured it as 91 degrees, I'm hoping you wrote it as an obtuse angle. But right here, it looks like it is acute. It's the same problem here. Go ahead and move on to this next one. Go ahead and have it lined up. Pick the bottom line to be my base. One thing to pay attention here, it is less than 90, so I know it's an acute angle. The next thing I want to be paying attention to is between the 70 and the 60. So the number has to be in the 60s, and it looks like it's right around 65. So write this as 65 degrees. Once again, if you got 66 degrees, 64 degrees, it's not necessarily wrong, but in this situation, it had to be in the 60s. So that's an acute angle. Let's keep moving along here. It's the same problem. One problem that did get skipped. We'll go back here and make a page for it. It says, draw a reflex angle and explain what is a reflex angle. Well, if I have an angle here, a reflex angle is this angle on the outside. Reflex angles are more than 180 degrees, but less than 360. Not 366, less than 360 degrees. That's a reflex angle. Put it on, write this 11-digit number. It's kind of blurry on here, but I'm going to take a look at my sheet. 1 in the ones place, it's right here. Put a 1 there. A 6 in the tens place, 6 right there. A digit in the 10,000s place that is twice the digit in the ones place. So the 10,000s place is right here. The digit in the 10,000 place that is twice the digit in the ones place. So the ones place is right here. Twice that digit would be a 2. 1 plus 1 is 2. The smallest even digit in the billions place, smallest even digit would be a 2. 3 in the tenths place, tenths is right there. 0 in all the other places. Hopefully you got that for a number. Problem 5. We'll kind of take a look at problem 5 here. So we're a little bit ahead of this pace. Problem 5 says draw an equilateral triangle. Well, kids, an equilateral triangle is a triangle that has all the same sides and all the same angles. The next one says draw an isosceles triangle that is not an equilateral triangle. An isosceles triangle, the definition for an isosceles triangle means you need to have at least 2 angles that are the same. That is an isosceles triangle. The last one says draw a scalene triangle. A scalene triangle, let's keep in mind, is a triangle that has all sides that are different. Here's my scalene triangle. All the sides are different from each other. What is one way a scalene triangle and an equilateral triangle are the same? Well, all the sides are the same length. Well, a scalene triangle, all the sides aren't the same. All have 60-degree angles. The sum of all the angles equals 180, or nothing in common. Whenever you have a triangle, kids, and you add up all the angles inside a triangle, will always equal 180. That's that magic number. Is this triangle scalene? The answer is no. This triangle is actually an equilateral triangle. All the sides are the same, which means all the angles are the same. So it is an equilateral triangle. Is this triangle isosceles? Are at least two angles the same? They sure are. If two angles are the same, at least two sides have to be the same. So yes, it's an isosceles triangle. Is this triangle an equilateral triangle? All the sides are the same. All the angles are the same. So yep, it is an equilateral triangle. Take a look at this one now. It's on your second page. It says for the polygon below, which are true statements? At least two angles are congruent. So I'm taking a look at this shape here, and it looks like I have a right angle here, a right angle here, a right angle here. So do I have two sides that are congruent? Remember, congruent means the same. I do. So I would go ahead and circle that. This is a regular polygon. Remember this word, kids. The word regular means all the same sides, all the same angles. And I can obviously tell here all the sides aren't the same, so I know that this is not a regular polygon. At least two sides are parallel. Well, let's take a look here. I know this line and this line will never meet. I know this line and this line will never meet. So to answer that question, at least two sides are parallel. That is correct. Go ahead and circle that. This polygon is a quadrangle. Well, let's count here. I have one angle, 2, 3, 4, 5. That's 5 angles, which means it's not a quadrangle. So I have to have A as a correct answer and C as a correct answer. Keep on cruising here. Got the shape here. This polygon is a quadrangle. Let's take a look here. Got 1, 2, 3, 4, 5, 6, 7, 8. Looks like I have an octagon on my hands, which means I have 8 angles, so it's not a quadrangle. No two sides are parallel. Well, this side and this side are parallel. This side and this side are parallel. This side and this side are parallel. I have a bunch of parallel lines, so I know I'm not going to be checking off B, because I have plenty of parallel sides. At least one angle is acute. All of these angles look obtuse. These are all obtuse angles. So I'm not going to be marking off C. Last one. This is a regular polygon. Are all the angles the same? Yep. Are all the sides the same? Yep. D is my answer. Let's keep on moving here. Find the missing angle. Here's the best part about this problem. We've been doing these every day for about 3 weeks. I have a straight line. What do I know about a straight line? Well, I know that a straight line equals 180. So when I add up these numbers, I have the number 53 plus 75. I'm going to add up those two numbers first. 8, 12. 128. 128, so I have to find out what the missing number is. 128 plus x equals 180. If I want to find out what x is, I have to better subtract, right? 128. Better write that just a little bit neater for you. 128 minus 180. Better borrow here. I've got a 10, got a 7, 2, 5. This becomes a 0. My missing number is 52. Keep on rolling here. Triangles. What do I know about a triangle? When I add up all angles in a triangle, that also equals 180. So what are the numbers I have? I have a 91 and I have a 36. Go ahead and add those up. 7, 127. Better find out what that missing number is, right? 127 plus x equals 180. Let's keep on rolling here. 180 minus 127. Better borrow. Becomes a 7, so I have a 3, I have a 5, a 0. My answer is 53. It's my missing number. Let's keep going. Find that what is angle G? Well, they all meet at a point. If I add all these up, a circle equals 360 degrees. That's one nice thing. Now I have 4 angles in here. So I'm going to take 360. I'm going to divide it by 4. How many 4s go into 3? 0. 4 times 0, 0. Subtract. Got a 3. Bring down the 6. How many 4s go into 36? 9 4s go in there. 4 times 9 equals 36. Subtract. Bring down the 0. Better get rid of this little 0 there. How many 4s go into 0? 0 do. 4 times 0, 0. Subtract 0. My answer is 90. It kind of makes sense though, because it's a square. The corner of a square would be a right angle, which would be 90. I just kind of wanted to show you how to solve that kind of problem. Any angle in a regular hexagon. On your study guide, you didn't have a chance to kind of see a hexagon, so I'm going to draw a regular hexagon right here. And let's take a look at, remember that one lesson when we figured out all the sides of a hexagon? So how many sides does a hexagon have? It has 6 sides. If it has 6 sides, it has 4 triangles. I'm going to show you again how we got those 4 triangles, but we know this from a pattern, right? If I'm picking a point here, I'm going to draw a line to all these points. Hopefully you remember this lesson now. So I have 4 triangles here. And what I know about a triangle is each triangle equals 180. So if I add up all the angles inside a hexagon, I would have to go 180 times 4. I could also add 180 plus 180 plus 180 plus 180, but I'd rather multiply. 4 times 0 is 0. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. So all the angles in a hexagon equal 720. If I add up all of these angles, it equals 720. The question asks any angle in a regular hexagon. So I just want to know what one of those angles are. Well, I'm going to count 1, 2, 3, 4, 5, 6. So I have to take 720 and divide it by 6. Kind of like what we did on this last problem with 360 divided by 4, because it was a triangle there. I mean a 360 circle. Well, here we're doing the same thing. How many 6's go into 7? 1. 6. Subtract, bring down the 2. How many 6's go into 12? 2. 12, subtract, 0, bring down the 0. How many 6's go into 0? 0. Subtract, 0. 120 is your number. Each one of these angles actually equals 120. With all those equal 120, if you add them all up, you get 720. Perfect. What region had the smallest population in 1900? Let's take a look here. 1900, I'm dealing with this column right here. Oh, what number is the smallest? Looks like my 2 million is the smallest, so my west region would have the smallest population. What region had the smallest population 50 years later? Well, if I'm starting here, 50 years later, better, some technical difficulties, kids, sorry. Try to get that not to move on me anymore. All right, if I'm starting here, 50 years later would be here. Oh, which one had the largest population 50 years later? Looks like the 85 is the biggest, 85 million. So that means which one had the smallest population? Better read the question, Mr. Green. Smallest population 50 years later, looks like my west region still had the smallest population. So west would be the smallest. Next question, which population had the greatest increase from 1850 to 2000? So now I'm going from here all the way to here. Now you could do a ton of long subtraction here if you wanted to. It would take you a while, or you could just kind of take a look at the numbers. Right here, 8 million, so I'm going to pretend this is an 8. Right here I have 86 million. So 8 minus 86, I have about a 78. See what I'm doing, kids? I'm kind of rounding. Let's take a look at this next number. I have another 8 here. Let's say it's closer to a 9, so I'll put a 9. Right here I have a 91. 91 minus 9 would give me an answer of 82. I'm rounding just to kind of see where I'm at. Midwest region, I'm going to round this up to a 4. I have a 93 here. 93 minus 4 gives me an 89. I'm just rounding the millions. Now I'm right here in case you missed it. 500,000 minus 9,600,000. So I'm right around, if this is 0.5, and if this is 9.5, I'd be right around 9. Long story short, kids, hopefully you were able to kind of see how I rounded there. I can help you more tomorrow with this. But what I'm trying to say is 89 is the biggest number by far. So the Midwest had the biggest change. So I have to take these numbers and do some long subtraction. I've got 93. Better give myself some room here. I've got 93,666,207 minus 3,927,339. I'm going to change colors here so you can follow along. Now, can I take 9 from the 7? No. So I have to change this to a 17. This becomes a 10, but then I had to borrow to get the 9. I had to borrow here, so which made a 1, but I had to make it an 11 because I had to borrow here, which would be a 5, which I had to change this to a 15. So I had to keep on borrowing because all these numbers up top are smaller from down here. But since I made this a 15, I have to make this a 5. I don't have to make this a 15 though, kids, because this 5 right here is bigger than this 2. Hopefully that made sense here. So now I'm going to take 17 minus 9. I'm going to get an 8. 9 minus 3, I'm going to get a 6. 11 minus 3, I'm going to get an 8. Put a comma here. 15 minus 7, I'm going to get an 8. 5 minus 2, I'm going to get a 3. Okay. Now I'm going to look here. Can I take 9 from 6? I can't, so I'm going to have to make this a 16. I'm going to have to borrow here from the 2, but the 3 is bigger than the 2, so I'm going to have to make this a 12, where I'm going to have to borrow from the neighbor, which makes it an 8. It's a long problem. It's pretty simple if you just take your time on it. Now I have to take 9 from 16, I have a 7. I'm going to have to subtract. 3 from 12, I have a 9. Then I have an 8. My answer is 89,738,868. We will be spending a little more time in class tomorrow doing some long subtraction with all the borrowing, but this is probably the hardest problem on the test tomorrow. Just go ahead and take your time. And write neatly, that's pretty important, but we'll be able to get this tomorrow. We already answered that one. One problem I did miss is problem number 13. Go back to problem 13, kids. I apologize. Name 2 adjacent angles. This angle right here is adjacent to this angle. So if I were to name them, I would angle EBA to EBD. EBD. If I also want to make, I could also write down EBD, angle EBD is adjacent to angle right here, DBC. They're adjacent to each other. They're right by each other. So just keep in mind, this one is right by this one. This one is right by this one. What you can't name as adjacent angles is this angle and this angle because they're not right by each other. This angle plus this angle plus this angle equals 180. Another problem that wasn't on here, problem 14. Using the straight edge. They want you to draw 2 angles. I want you to label them A, B, C, D, E. It says use a straight edge to draw a pair of adjacent angles. Make one of the angles obtuse. Use the letters to name the angles. Tell which angle is obtuse. Okay, my obtuse angle, obtuse, would be angle ABC and angle DBE. These 2 angles are my obtuse angles. Without using a protractor, estimate the measures. Well, let's take a look here. This angle right here looks like about 30 degrees. If this is at 30 degrees, its vertical angle or opposite angle would be right here, 30 degrees. Now we have to keep in mind, this is a straight line. With this being a straight line, kids, we should know what this angle is. 30 plus 150 equals 180. If that's 150, this is 150. It will make sense then. If I draw this line right here, that means this angle and this angle together equal 180. This angle and this angle equal 180. Also on the website, please take a look at the challenge problem. I have that recorded as well. Good luck. Sorry this video got a little long, but trust me, it will help you tomorrow on the test.